Okay, this is lesson 3-4, Arithmetic Sequences. You might hear it pronounced arithmetic or arithmetic. I'm going to stick with arithmetic just because out of habit. So let's talk about what a sequence is. Guys, a sequence is just a list of numbers, okay, that are connected through a pattern, okay? So we've talked about patterns a little bit, but now we're going to talk about this specific kind of pattern called an arithmetic sequence. So this sequence, 25, 37, 49, 61, 73, this is made up of 5 terms. So each one of these is a term. Okay. Now you can have less or more terms. You can go on infinitely. All right. Now the question is, how do you know if something is arithmetic? So is this arithmetic? Well, the way to prove if something is arithmetic is to look at the gap between the numbers. We call this the common difference. Okay. They should have the same gap between the numbers. Okay, so we call it the common difference. So if you're not sure what it is, you can take the number over here and subtract this one. So 73 minus 61, or 61 minus 49, or 49 minus 37, or 37 minus 25. If you do all of that, they'll give you the same numbers. Or you can just look at it. How do I go from 25 to 37? How do I go from that number to this number? Well, it's increasing, so I'm going to add. What are you adding? 12. And then you would check, are all of these adding 12? Yes, yes, yes. So the common difference, D, is 12. And this is arithmetic. They have to have the same difference between the numbers. If one of them is different, like if this was 13 and went to 74, it's not arithmetic anymore. Okay. Another way you'll see it kind of identified is like this. What are the 5 terms? Oh, A1, A2, A3, A4, A5. So A1 was the first term, A2 was the second term, A3 was the the third term, the fourth term was 61, and the fifth term was 73. So you'll see terms identified like that, okay? And then to solve for certain terms, they have this equation or this formula called the recursive formula. AN equals AN minus 1 plus D. Okay, so if I'm looking at this sequence right here, and I find the common difference between these numbers is adding 12, well, then this is the formula. That's it. That's the recursive formula. How do you get to the next number? Well, you have to add 12. All right. If this was in a table, you would see it kind of organized like this, where n represents the term number. So you're looking for term number 1, term number 2, term number 3, term number 4, term number 5. And then an is the actual term. So this is one way you can see it organized. Okay. So let me do a quick example just to kind of show you how this works. I'm going to do it up here. Okay. So let's say you want to find the 6th term. You're looking for A6. Okay. The formula says right here, you're going to plug in 6 into the formula. And the common difference was 12. Okay, now you notice this is 6 minus 1. Well, the reason they put 6 minus 1 is you have to use the term that came before 6. What is 6 minus 1? 5. So that means you have to use the 5th term. Well, the 5th term is 73. So how do you find the next term? You take 73 and you add 12. That's how you get the 6th term. So 73 plus 12 would be 85. So A6, the 6th term, would be 85. Now, of course, you say, Ms. Morales, that seems really complicated. Couldn't I just do plus 12 here and get the same answer? And you are correct. The reason they teach you this formula is because this is only for arithmetic right now, but you're going to learn about other sequences that are a little bit more complicated, and this is very useful. when it's a little harder to do. Okay, so example number 1. Let's write a recursive formula for this. So remember the recursive formula? You need to find the common difference between the numbers. Now these numbers are decreasing, so the gap between the numbers, the common difference between the numbers, is going to be subtracting by 3. So I would write -3, like that. And that's a recursive formula. That's it. Okay, let's go to the next one. Example number 2. So let me pull up the picture for this. So example number 2 is asking about what is a recursive formula for the height above the ground for the nth step of the pyramid shown. So nth step just basically means you're writing this for the nth step, the unknown step. It's your variable. Okay, so what information do they give us? Each step is 26 centimeters tall. So again, we're using the recursive formula. So with the first step is 26, the next step would be another 26. So really, the common difference is just going to be 26. And your sequence will look like this: 26, then it'd be 52, then it'd be 78, and so on and so on and so on. You'd be adding 26 to each term to get there. Okay, but yeah, this is the formula. Now, there are other formulas. For example, there is this one called the explicit formula right here. And the explicit formula looks like this. Okay, so it looks a little bit more complicated. So let's talk about it before we write it down. And let's use the same sequence. This is supposed to be 49. Sorry, I made a mistake copying. Let's use the same sequence. Okay. Now, I like this one more because I can find any term with it. With the one up here, I could find the next term. I could find A4, but I couldn't find A10 right now. If I wanted to find the 10th term, I couldn't use this right now. I would first have to find A4, then 5, then 6, then 7, then 8, then 9, and then I could find 10. So this recursive formula is only good for finding the next one. It's kind of hard to do it if they're asking for a term that's really far away. All right? In those cases, I would rather use this one with the explicit formula. So let's talk about it. You first need A1. Now A1 was the first term, so in this case that would be 25. Okay, n minus 1 is now not just a little notation, it's not a little subscript. N minus 1 is now a regular number. Before, when they're little numbers like this, they're just kind of identifying which one you're using. So here, A1 is asking about the first term. The last thing I need is the common difference. Now, the common difference in here, we said earlier, was 12. Right? And that's how you would write it. But the next thing you'd have to do is to simplify this, because that really makes it complicated. So the first thing would be to distribute 12. So when I say distribute, we mean multiply. 12 times n, 12n. 12 times negative 1, negative 12. Oh, wait a minute. There's two terms here, 25 and 12. What can I do here? Oh, I can subtract 12 from this. That would make it 13 plus 12n. And ladies and gentlemen, this right here is the explicit formula. And what this one lets you do in this problem up here, now if you wanted to find A10, I don't need to find 4, 5, 6, 7, 8. I can ignore all of them. If you want to ask me what the 10th step height would be, I just plug in 10 and I could find it. So that's why I like this one more. I like this one because you can find any term. I don't just have to find the 6th term. I can find the 10th, the 15th, the 50th, the 100th. And all I have to do is plug in the term that I want. Okay, so for example number 3, we're going to use a table. So using the table, what is the cost of renting a bike for 10 days? So the reason I want to go with this one is because sometimes you'll see prices for like, oh, stay a night, stay 2 nights, stay 3 nights. They'll give you prices for like the first couple charges. Well, what if you want something long term? Well, traditionally, what you'd have to do, if you're at number 4, you'd have to go then, okay, what is 5? What's 6? What's 7? What's 8? What's 9? What's 10? We don't have to do that anymore. If we use the recursive formula like this, we can now find the cost of 10 days pretty quickly. So let's look at this problem. So we have the first term. So remember, we're using now the explicit formula. And the explicit one looks like this. Okay, that's explicit. The first term is the first charge, which is 26. And then leave that the same. The common difference between 26, 38, and 50, oh, it's 12. How about that? It's 12 again. I wish I had chosen a different number. All right, I multiply. So now I have 12n, and 12 times 1 is negative 12. Oh, so again, you notice you're subtracting the common difference from that first number. That's interesting. That would make that 14. Okay, so there's my explicit formula. So now, if I want to know the cost of renting a bike for 10 days by using this chart, I just got to plug in 10. So, A10. What is the 10th term? Plug it in. Now that's 120 plus 14. A10 would be $134. That would be the charge of renting the bike for 10 days. Okay? And that's how you use it. Pretty straightforward. Now, if you're going to graph this kind of information, sorry, I had a little typo. Now, if you're going to graph this kind of information, you can think of this as coordinates. So for example, there is no point at 0 because your terms don't start at 0. Your terms start at 1. What is the cost of 1 day? 26. What is the cost of 2 days? 38. What is the cost of 3 days? 50. And what you would see is a set of points that is increasing or decreasing. Now we don't draw a line. We leave this discrete. We don't connect the dots because you cannot rent the bike for 1.5 days. You can't do that. You can rent it for 1 or 2 days, but not for 1.5. So you don't connect the lines. You just leave it as points. Okay? All right. The last couple things. How do you change it from explicit to recursive? So what if they give you this formula, but you don't want this formula anymore because it doesn't work as well? What if you want the explicit? So remember, the explicit is this one. Okay, that's the explicit. This is the one that lets you solve for any term anytime. The recursive only lets you do one at a time. Well, you need the first term. So we need that. Okay. The next thing we need is the common difference. So remember, this formula, the recursive, you only plugged in one number, D. This was the common difference. So right here, we're putting in -3. So now we have to change this. So we're going to distribute. Remember, got to multiply both of them. So you get, yep, -3n and +3 because a negative times a negative is positive. This 3 will combine with the 10. So now this is what it looks like. And that is your explicit. So you took the recursive formula and you just wrote it now as explicit. Now you can solve for any term you want. All right, let's switch it around. What if they want the recursive and they gave you the explicit? Okay, so the recursive one is just this. What's the only number you need? The common difference. Okay, if I look at this, which of these is my common difference? Well, let's take a look at this one. The common difference is multiplied to two numbers right here. But then this one combines with that. This number didn't change. This was your common difference, the number with n. So when you look at this, guys, the common difference is the number with n. In this case, it's 3. So all you have to do is this. There's the recursive formula. That's it. Of course, if they want you to find the first term, it's really easy. You just got to plug in whatever term they want. So if I asked you to find the first term, all right, plug in 1 for n. So 3 times 1 is 3. 8 plus 3 is 11. So that would be your first term. So that's just if they ask for that. If they just want the formula, this is fine too. And that's it, guys.